In this video, we're going to solve a word problem involving antiderivatives and motion. It says a particle moves in a straight line and has a velocity given by v of t equals t squared minus 7t minus 1 meters per second. Its initial displacement is s of 0 equals negative 1 meters. Find its position function s of t. Well, if you remember from previous assignments, s of t is the position function. When you take its derivative, you end up with the velocity function. And when you take its double derivative, you end up with the acceleration function. So what they're asking us to do is they're asking us to start with a velocity function and then work our way backwards to just the original position function. So we're going to have to take the antiderivative for this. So to do that, we're going to say, I'm going to say s prime of t is equal to t squared minus 7t minus 1. And then I'm going to take the antiderivative of this. So s of t is going to equal, the antiderivative here would be t to the 2 plus 1 divided by 2 plus 1 minus 7 to the t 1 plus 1 divided by 1 plus 1 minus 1 t to the 0, because there's no t there, so t to the 0 plus 1 over 0 plus 1. And then we have this plus c constant at the end. So s of t is equal to t cubed. This would actually be 1/3 t cubed minus 7 over 2, because of the 1 plus 1, t squared. This will be 1 over 1, so it's just minus t, and then plus c. Now they tell us something significant here. They say s of 0 is negative 1. Well, this whole constant term is what we need to figure out here. So we're going to take and plug 0 in for t, and then negative 1 goes for s of t. So we have negative 1 equals 1/3 0 cubed minus 7 over 2, 0 squared, minus 0 plus c. So we end up with negative 1 is equal to c. So our original equation is s of t is equal to 1/3 t cubed minus 7 over 2 t squared minus t minus 1. And that's our original position function. And we got there using the antiderivative of the velocity function.